Hello. So this talk is about managing complexity with Terraform. Tips and tricks from the trenches. I work in cloud. I build a service in Oracle's cloud. We use Terraform for everything, pretty much when it comes to infrastructure, application deployment as well. So, been doing it for a little while, and just figured I'd come out and try to share some things with folks who may be newer to it. Maybe you're getting started and things are getting complicated. So some of this is just about how to manage that complexity. First, inside every developer that does Terraform, there's really two wolves. There's a conflict. You guys all know the parable about two wolves inside of a person? The first one prefers code that is easy to read. The second one prefers code that is really easy to maintain. A lot of times in Terraform, you end up having a trade-off between is it easy to read or is it easy to maintain? The one that wins is the one that you feed. Luckily, with these two wolves inside each developer that does Terraform, they both agree that well-organized code is the most important factor of Terraform. So whichever way you choose to go, as long as it's well-organized, that's the most important factor. And we'll talk about why as we get further along into the talk. Who here has ever been to one of these? Yeah, not a surprise, right? Now I'll go back a little bit further in history, maybe date myself a little bit. Who's ever been to one of these? A couple of you. So like the grocery store and the library, even Blockbuster, what do all these things have in common? They're really well organized usually, right? You go in, it's a late night emergency, you forgot some condiments and you're having a party the next day, you need to get some ketchup, you know right where it's at in the store because it's usually well organized, right? Your Terraform code is kind of that same idea. It should be well organized, even if you choose to make it easier to maintain or you choose to make it easier to read. And we'll see some examples of what that means shortly. My name's Justin Biard. Like I said, I work at Oracle. I'll throw again the QR code up at the end of the presentation, so no worries if you can capture it now. I've been at Oracle for about 3.5 years, working in Oracle Cloud Infrastructure as a software engineer. We're going to talk about what is Terraform for the folks that may be newer in the audience, online or in the room. We're going to talk about managing complexity for most of this talk. It's not going to be every edge case. We're not going to cover all the syntax features of the Terraform scripting language known as HCL. At the end, we'll look at some resources like where you can go to get more information from here because, quite frankly, the documentation is excellent and you should definitely check it out. So what is Terraform? It gets really, really boring talking about Terraform because it's a kind of a boring thing. It should be somewhat boring, right? But we call it infrastructure as code. What that really means is you write code and you turn that code into your infrastructure in the cloud somewhere or locally. It doesn't have to be a cloud, but it usually is. Terraform is also a tool that lets you build, change, and version control your infrastructure. So as you write your code, you're going to be able to keep track of the changes that you're making to your services or to your applications. So this first part, what is Terraform really doing? You're writing code, and then you're doing some magic in the middle, and then on the other side of that pops out a network, some cloud compartments, a compute instance, maybe a load balancer. Think about infrastructure in those terms. That's what it means in this context. So you write your code, you call Terraform apply. That does the magic in the middle. Usually that's done through something called a provider. We'll look at those in a moment. And then on the other end, it goes to your cloud service, whatever that is. There's a lot of different ones that support Terraform. Here you'll kind of see the pattern show up a lot. Now at the very end of that apply, what usually happens is, okay, I've got some code changes. I added some new resources to my infrastructure. I'm going to version control the code so I know what changed, right? I'm doing a pull request. Someone says, yeah, that looks good to me. Gets saved into the version control. At the same time, Terraform is keeping track of the state of your infrastructure, and that's really important. So it's agnostic by design. Terraform doesn't really care what your target environment is. In fact, you can even use Terraform locally, right? You can use it as a tool to manage containers on your desktop. And if I have time during this talk, I'll do a quick demo and show you what that looks like. But then how does it talk to all the different clouds? We talk to Oracle Cloud or AWS or Azure or GCP. We're using something called a Terraform provider. And that provider is the plugin for Terraform that lets you talk to each cloud. Okay, makes sense? All right. Some alternatives if you haven't used Terraform that you might look into. If you're interested in staying away from Terraform for some reason, OpenTofu is an open source variant of Terraform that you could look at. Maybe you've heard of Pulumi or CloudFormation. Those are all infrastructure as code solutions that you could also use. I use Terraform, so I'm here talking about Terraform. All right, so let's kind of get into managing complexity and what that looks like in Terraform. This is going to be code snippets, examples, and we'll just kind of walk through them. And if I can, I'll also show you some live examples. So what are examples of complexity? When you get started working in Terraform, it's kind of like, okay, what do I do? How do I structure this infrastructure thing? How do I write my code and start putting code into files? And at some point, you get to a situation where you have, there's a lot of repetition in my code. There's a lot of things that look complex or they're hard to read. So the first level is kind of like, when I say level, I mean like the easiest things you could do to start out are dealing with adding local variables in your Terraform code to help refactor things. You can add variables as inputs to your Terraform, so that lets you kind of parameterize your infrastructure before you apply it. You can also split your configuration into modules, and we'll look at examples of that shortly. And then this is kind of, maybe it's opinionated, but Terraform offers you a tool that lets you format your code. And if you apply Terraform format before you do your PRs, and everyone does the same, then you'll start noticing that the consistency. You know what to look for, you know how it looks, you kind of notice the indentation's consistent. So maybe that's not a new concept, but you get it for free with the command line. Kind of the next level, and it increases in complexity a little bit, that you're increasing the risk, or remember the wolf who likes to read the code versus the wolf who likes to maintain the code. So breaking your Terraform up into multiple modules helps you maintain the code, just makes it easier to maintain, but it also makes it a little bit harder to read, and you'll kind of see those side by side in just a moment. And last, when you have multiple deployment shapes or environments, let's say you have a development environment, you have a production environment, maybe in development you're trying something new and you don't want to deploy those resources into your production environment. So how do you make that happen, right? How do you make your environment conditional? This is really flexible, it's really powerful, but it's also really dangerous. What if you accidentally turn off your database resource for production and you apply your Terraform change and you delete your database, right? That's a bad thing. So it's really powerful. Just keep in mind that it's also somewhat requires great responsibility. All right, so this first thing we talked about is how do we make Terraform code a little bit easier to maintain, sacrificing a little bit of readability. So we can add something called locals, or a local variable, into a Terraform script. And what this allows you to do is it gives a semantic name to what would otherwise be a hard-coded value. Now that's good for maintainability, but it does impact readability, because when you're reading through Terraform code and you're like, what is 8080? Well, probably a port. But when you start seeing those numbers or things hard-coded in Terraform all over the place, it can become a nightmare to maintain as you get to the hundreds or thousands or tens of thousands of lines of code. So local variables help to give semantic meaning to a name. Maybe you have multiple services, one running on a port A and one running on port B. If they happen to be the same port when you start your project, but later you want to refactor and change the port for one but not the other, find replace doesn't work anymore. So in those situations, local variables can really help. It also simplifies or reusing expressions. So if you start getting into complex expressions in your Terraform code, sometimes adding a little explainer variable in there just to say, hey, this is what this means. This gives it some meaning. And then when you use it later, you'll kind of understand intuitively. On the downside of it, though, overuse, it really does make your code harder to read, right? If you have variables that you've sprinkled throughout your Terraform code, you've kind of got to go back and forth to find the variable, figure out what the variable means. So it is a pro and a con there, but it's which wolf are you going to feed, right? So here's an example. Creating a load balancer resource. This is not specific to any cloud. This is the structure you'll see regardless of what provider you're using. When you're creating a resource, you'll have some kind of a resource type. You'll give it a name. In this case, I called it some listener, and I give it a port 8443. Okay, and then later on, I have a firewall that I've defined. Again, this is not specific to any cloud. This is just to kind of give you a visual image of what this topic is referring to. So in both cases, I have this port 8443, 8443. No big deal. It's 3 values. If your code is relatively small and you have this going on, this is actually probably preferred because it's very easy to understand exactly what you're doing. And if something changes, it's very easy to see in the code why it changed. On the other hand, if you have this all over the place, you can introduce something called locals. Now, locals will allow you to refactor some values out. In this case, I'm doing something very simple where I'm just taking the port, adding a variable name to it, and then I'm using that variable throughout the same blocks In this case, it's a no-op change. If I applied this, there would be no change in the infrastructure when I apply it. It should just be a refactor, make it easier to maintain. All right. You guys all see this okay? So this is Terraform. And we have a Terraform in a directory structure. There's no magic here. You just create a folder, you create your Terraform files in it, you initialize Terraform in a directory, and what happens is you configure providers. In this case, those providers we talked about, I only have one set up here, and it's really, I did it for local development. I'm saying, okay, I want to just manage Docker containers locally. I don't want to do anything in the cloud in this demo. I'm just doing it just to kind of give you an example. And then I've created a resource here, Docker container, called it backend, wasn't very creative, and I gave it a port. Now, if I go over and run what's called Terraform plan, you'll see Terraform is reading in that configuration, and it's trying to figure out what's different. What did I change? In my code, I added a container, so when I do a plan, I can see, okay, I'm adding a container. And this is very important if you have critical infrastructure, is that someone's able to review the changes and see what would be different if I apply this infrastructure. All right, so if I go here and I say Terraform apply, you can auto-approve if you want, if you know the change is not going to break anything. In this case, you can also just say yes. And Terraform has now created a container locally on my machine. It's pretty cool because, is that interesting? Is that, yeah? I think it's really fun to be able to play with Terraform locally and try these ideas out and not worry about breaking prod or breaking your shared development environment. Anyway, so I can prove that's doing a thing. You can see, okay, I now have a container running. And if you have great power, you also have great responsibility. You can also then delete production accidentally, right? You got to be careful with it. It's just, you can see how quickly you can get into a situation where you're like, I didn't mean to destroy that. All right, so that's local variables. You create resources. You can then define variables or parameters to those resources using variable locals if you want. The next topic is kind of related to locals and variables, so I kind of club them all together, which is string interpolation. There's a lot of times in Terraform where you're giving a resource a name. You're like, okay, it's going to be something XYZ dev, something XYZ prod, or you're giving it some other suffix for some reason or prefix. With string interpolation, you can essentially do, if you're familiar with Python F strings as an example, you can take an F string, you can put a parameter inside the string, prefix the string with F, and Python will interpret the value as part of the string. Terraform can do the same thing. This is really good when you have like external inputs driving your configuration. It's good when you have things like dynamic display names. It's also useful in the context of modules, which we'll talk about shortly. On the downside of it, variables can increase complexity again. We're kind of going away from the readability, going towards maintainability. So which one of those two things are you going to feed, right? Like, to me, sometimes they can both work out just fine. Sometimes you have to make choices. So here's an example. We've already seen locals, so nothing new here. I've created a local called stage, set it to dev, and then I've created a resource, a compute instance in this case, and I'm calling it API instance local stage. Well, we can see all the code in this instance on one screen. It's fine. You can see it's dev. It's going to create a name called dev. But in reality, when you have tens of thousands of lines of this going on, sometimes that's where you kind of need to remember you're switching context. So it's a trade-off. Now here's an example that's a little more complicated than a local, right? I'm declaring a variable now, which is a kind of same thing. It's not local to the file, but essentially it's allowing me to define an input to my Terraform infrastructure of code as a whole. In this case, I've declared a variable called stage. I've given it a type, string, a description, and a default value. Same idea. Instead of hard coding dev to one local, I've created a variable and given it a default value. Now, whenever I run my Terraform plan here, essentially it would do exactly the same thing. There would be no change. All right, so let's say, go real quick with this. Now, if I go back into GitHub or into this code, you'll see some differences here. So I've created a variable, I've given it kind of a default name, and I'm actually doing something a little more tricky here. And I'm introducing a new concept, probably before we just talked about it, but that is conditional expressions. But when you start adding variables into your code, it's usually not just to do a string concatenation. Usually you're doing something conditional inside your Terraform. In this case, I've created a variable for stage. And if I go back to Terraform, you saw me do Terraform plan a moment ago. I've aliased that to TPD because Why not? You can see we were, again, just creating another container. No magic there, right? Pretty easy. Add a variable, do a thing. Now, if I come back and I say, you can see here the port is 8000. If I say, sure, stage is prod, you can see I'm getting a different external port now, 9090, right? Because I've set it up to be conditional in my Terraform. Uh-oh. Anybody ever YubiKey their code in the middle of a demo? I have, apparently. All right, so conditional expressions. We just saw an example of it kind of live, but essentially it's often paired with a data. So in Terraform providers, usually there's two things you get. You get a resource type or you get a data block. Essentially what those allow you to do is query information from your infrastructure. You say, hey, given some data in my existing infrastructure, I need that information to do other things down the road. Maybe you're setting up dependencies and you say, okay, I don't want to deploy this compute until I have a network. So conditional expressions are really useful when you're altering parameters based on those inputs. And then, of course, the downside is when you start getting those expressions, they're ternary. So you start nesting them, they get really deep, it gets really ugly really fast. Again, we go back to the variables and locals concept. You start when you start getting really complicated expressions that are just difficult to parse mentally, consider using locals and variables, and then using conditionals. So here's an example before. It's kind of silly, I know, but it's where we're at. So I've created another set of locals. I've defined another local variable for service port. And hey, if the stage is dev, use 8080 because I'm not using SSL. I just want to use, open port. And if I'm using prod or really anything else in this case, assume it's SSL encrypted and use 8443 instead. But then again, I just pass in the local variable into my parameters of my resources in Terraform. All right, so putting it all together, you've seen how I did Terraform plan, Terraform apply, and that kind of creates the resources. In my example, I used dev as a port for default 8080, and I used something else, in this case, prod as 8443. That's kind of simple. Does that seem okay to you guys so far? Everything good? All right. Modules. This is where it starts getting, when you're refactoring all your Terraform code, and you're like, man, this is just kind of getting to be a mess to maintain. I had a fire drill in production last night, and I had to look through like all this code to figure out what broke. And this is where modules kind of come into the picture. So modules are great. They allow you to reuse groups of resources. So let's say you're defining 10 things, you copy paste, define 10 more things, you copy paste. Anytime you get to that stage of Terraform where you're like duplicating code, that's a good signal that it's time to start thinking about using modules. It also really does simplify maintenance for larger configuration. So, if you have a massive prod configuration and a mediocre or small dev configuration, you can start using modules to help reduce the amount of things you need to copy paste everywhere. On the downside, it is harder to read without navigating to the source, right? It's an abstraction, so it kind of hides what's going on. It's really opposite of what you want Terraform to do. Terraform should be easy to read, but unfortunately, sometimes you also need easy to maintain. And then with Terraform refactoring to modules, you have to be aware of address changes, right? So if you change the address of a resource in Terraform, Terraform is going to assume it doesn't exist. What happened to it? It's going to either try to recreate it, or it's going to try to delete the existing thing. So you kind of have to have a strategy for how you deal with that. So let's talk real quick about what module refactoring looks like, and then I'll try to show you a demo. So here's my before picture. This is my quote-unquote easy to read version, right? If I'm going to take this and get rid of some of the duplication, I need to isolate the things that are different between all the duplicate settings here. And in this case, I have a listener, a firewall, another listener, another firewall. One was created for dev, one was for prod. And the only real differences between those things, in this example at least, are the stage and the port that I'm using for those two resource groups. So how do I then take that? Well, first I would create the module, and then I would, instead of defining the resources directly in my main TF or wherever I'm putting my code, I define a reference to the module. I say, here's a module. Here's a source to where you can find the module code. Here's the two parameters that I just declared. One was for stage for input, the other was for a port. So the typical scenario here is you start building your Terraform. It starts to get complicated, and you think, I may need to refactor this. It's just getting hard to maintain. So you do that. You take the larger chunks out of your big infrastructure configuration. You create the modules out of those. And then you reference the modules instead. Maybe your production environment has slightly more or slightly fewer modules. Again, earlier we talked about adding a feature to your application that maybe only applies to development testing some new tech that doesn't need to be in project. Modules are a good way to make that happen. And then to be able to reuse it later when you're ready to go live into a different stage. All right, so let's see if I can show that. I'm running out of time, or is it just, I'm good. I'm going to create a container. Okay, I've got my container running. And I'm going to pretend I've just made a change to create some modules. Let's take a look at the code real quick. So you've kind of seen this before. I've got a variable for stage on input. I've got another variable for the port. And here I've got this thing called move. So if I get rid of that for a moment, and I go back to Terraform, and I pray that it worked. Yep, good. All right, so if I do a plan, it's going to say, hey, you're adding a container. But it's also going to say, hey, you're actually deleting a container, right? Like, yeah, you put this thing in a module, but the address in Terraform state lived at point A, and you moved it to point B. Now Terraform doesn't know. It just thinks, hey, you deleted that thing. So one way to handle that situation, at least if you're on Terraform 1.5 and newer, is to come back and say, you know what, Terraform, actually this thing does still exist. It just exists somewhere else. And that's done with a move block. There's other ways to handle this scenario, but in 1.5, they added this little bit of archaeology. Okay, look for it in point A. Terraform will now know, okay, it's moved to point B. So if this works, just give it a shot. Now you're seeing Terraform doesn't want to recreate anything. It doesn't want to destroy anything. It's just storing a reference to that move, saying, okay, I know I moved. Does that make sense? Good. All right, that's modules. So I took the original Docker container definition out of my main TF, moved it to a module, referenced it. So that refactoring, keep in mind, if you do refactor for modules, it's great for organization and maintainability, hurts readability a little bit, increases the risk in terms of, hey, I might actually delete resources if I'm not careful when I do it. Just plan ahead. It's not the end of the world. It's not super difficult. Conditional resources, this is kind of the last real thing, which is, hey, I've got features I want to deploy into an environment, but not another. I have a development instance I want to put on dev, something else in prod. It's great when you need to enable or disable a single resource, but you can also now, I think Terraform 0.13 allows you to conditionalize modules. So you can have actually entire groups of resources that you turn on or turn off, depending on some external parameter. It can make your difficult configuration really hard to reason about, right? Because you won't know except at runtime what's going to happen. So that's where that reviewing the Terraform plan can really save a lot of headache. Is, am I going to drop things I didn't plan to drop? Am I adding things I didn't plan to add? And unfortunately, with conditional resources, there's a non-zero chance that you're going to delete things you didn't intend to delete, right? So just make sure if you are making that kind of change, that you review those plans pretty thoroughly. All right, so here's an example. I have a resource and I have a module, and right now they're not conditional. I add a local, which you've all seen before. Now I'm just saying, hey, is it enabled or not? Whatever that thing is. Like you'd use something more realistic in your prod code. Here I'm just saying, is it enabled? Yes or no? And I'm able to use this meta argument called count. And with count, in this example, I'm using it as a flag to disable the resource. If the flag is enabled, I get a resource because the count is 1. If it's disabled, I get a 0, so therefore I get no resource, right? So that's kind of how it plays out. All right. So some hypothetical requirements changed. Maybe you have a load balancer, extra compute instance in prod, or something else in dev, and you set that variable to false for dev. You deploy your infrastructure, you get onto the network and maybe some API instance. But what about prod? So you set it to true for prod, you deploy, and now you get the extra resource in production. So that's the whole idea behind conditional resources. All right. So some resources, where to go from here. How do you get more info on these topics? Quite frankly, the developer documentation for Terraform is fantastic. Okay, start there. Tutorials are great, that's fine. They have a lot of info on all the syntax, and the tips and tricks you can get from them are actually really, really fantastic. If you prefer the open source variant, there's OpenTofu. Their documentation's okay. Still start with the Terraform docs because OpenTofu is a fork of Terraform, so they're very compatible. Providers, check out their providers there for your clouds. Every major cloud has one. Also, the code that we looked at, the demos here are available on GitHub. If you care to look at them, they're kind of basic, but at least they give you something to start with playing. And if nothing else, I hope they encourage you to play with Terraform locally and try out things that you can do to refactor your code. So just to recap, we looked at what is Terraform. We talked about infrastructure as code. We talked about managing complexity and gave you some extra resources from where to go from here. Prompts for the images, because why not? Thank you.